Okay, so for this problem, we are looking at the rate constant and activation energy. The question asks, for a certain reaction, the frequency factor, A, is 2.7 times 10 to the positive 9 over seconds. And the activation energy is 18.1 kilojoules per mole. What is the rate constant for the reaction? So for this problem, we are going to use the infamous Arrhenius equation. There's a couple of different forms of the Arrhenius equation, but the one that we're going to use right now is going to be solving for K specifically. Now remember, it's little k. Little k is the rate constant. Big K, if you haven't been introduced to it yet, stands for equilibrium. And there is a difference. So little k is going to equal the frequency factor, A, times E to the negative exponent of our activation energy divided by RT. So in this problem, we're going to use R, so you know we're dealing with a gas, obviously, and that's a constant. T is temperature, which is going to be in Kelvin. And everything else is given to us. Actually, in the problem, it also says that the reaction happens at 85 degrees Celsius. So now we have everything. So we're going to simply plug everything in. Our frequency factor is 2.7 times 10 to the positive 9. Multiply that by the number E, which is raised to the negative. Our activation energy is given to us in kilojoules. When we use the Arrhenius equation, we need to put that into joules. So this will be 18,100 joules divided by the rate constant, which is going to be 8.314. And our temperature is in Celsius, and we need to have it in Kelvin. So 273 plus 85 gives us 358. And all you need to do is plug all this into your calculator. Make sure you use plenty of parentheses. And you find that the rate constant will equal 6.17 times 10 to the positive 6. And that is your final answer. Take a good look at that, work on a few more, and best of luck.